hear me? Can you hear me?
Yes.
Okay, thank you. So, hi, I'm Roberto Bettazzoni. I want to talk to you about why you need to change your way of working. Few words about me. Here's important. And I'm a software craftsman. I'm working as an Agile coach and technical trainer, mainly. I work with software from a long time, and now I mainly make Agile coach for Scrum teams, a lot of Scrum teams. So the content of my talk comes from direct experience during last years. So, why should I change my way of working? There's a lot of reasons to change your way of working. This is a technical conference, so I want to talk only about technical reasons to change your way of working. There's a lot of good reasons to change your way of working, like marketing, like HR, people are different. There's different way to sell products. We don't sell really products right now. We sell more services to our customer. It's more likely that you are selling services, not products. But I want to talk only about the technical part of our way of working. So how we build software. I know that is not the main part, but let's concentrate on how we build software nowadays. And to keep it simple, I want to focus on a product. I know that we don't build a real product right now, but let me concentrate on product, and then we can extend on real services later. Okay, let's start. Why should I change my way of working? To build complex products in a more effective way. Very simple, I can stop now. Okay? We have a complex product, we are not so efficient in building it. So let's say analyze a bit why. What is product complexity? Product complexity is something formed by different layers. Let's analyze the source of complexity. There's an internal complexity. Your software has an internal complexity. This is given by your functionality. The set of functionality that your software has to perform. There's an internal complexity. If you have a software that simply makes an addition of integer, or if you make a comparison between satellite maps, there's a different internal complexity. I don't care about the language of the code or how the software is structured. There's an internal complexity, and this internal complexity cannot be reduced. So you have an internal complexity that is given from the functionality your software has to perform. Then, on the top of this complexity, you put the technical complexity. So your languages, your frameworks, your continuous deployment stuff. If you have this software on the cloud, maybe there's you have some complexity and so on. So you have different, your complexity is increasing. At the beginning of the project, you don't know really well your product. So there's an unknown part in your product. The unknown part can be very, very, very big. Let me say, if you can have 4 levels of unknown. You did something similar. Okay, your customer asked you for something and you did something similar. So the unknown level is not so big. You make it something similar. You or your team. Second level, someone else did something similar. So you can hire an expert. There's someone you know that did something similar. So you can hire him or her. The third level is you don't know. There's no one that did something similar, but you read on the internet that someone has used that technology or built something that you think can be similar. And this is the third level of complexity. The fourth level is you know nothing. You are a startup. You are making something completely new, with new technology. And the unknown part is very high, very big. So your main problem is not how to build it, to understand what to build, and then how to build it. And this is the higher level of unknown, and this introduces a lot of complexity in your project. In spite of what is the project, I don't care about the internal complexity. If you have nothing similar to compare, you enter in the unknown domain. And if you don't know what you need to know, it's much worse. Okay? So when you are a startup, you don't know really the list of things that you have to know to build your product. And this is the unknown part. And then there's the cultural, last but not least. The cultural part is the difference between your culture and your customer culture. If you are talking with a bank, maybe you can understand the difference of culture, the clashing of difference of culture. And this is a communication problem. So you talk a different languages from your customer. Your customer thinks, when you think about a server, you think about an Amazon account. Your customer think about a big gray machine full of lights and cable. Maybe it's better that you talk with your customer a little more. Okay, there's another cultural problem that is internal culture. So you are used to work in your way from 20 years. Now the time is changing. 20 years, 15 years ago, was invented the Agile Manifesto, was written the Agile Manifesto. 15 years ago, okay? It's a lot of time, 15 years ago. There was a Nokia phone, you know the cell phone Nokia? Okay. 21 was the day in which Windows XP was released. The release of Windows XP. Who use now Windows XP? Not so many. Who runs Scrum? Who has the Scrum team? Who knows Scrum? Okay, same here, 2001. Scrum, the first Scrum book was printed in 2001. Okay? Okay, it's different, but that's a lot of time. The cultural, if you are running Scrum for a long time, you have acquired some way of working, and to change the way of working is something difficult. So there's a big inertia, and I want to talk about that. Okay? So there's another problem. The complexity changed during the product development. You start from a higher level of complexity to arrive, hopefully, to a low level of complexity, hopefully. Okay? So I started, I don't know very well my product, because I have some talk with the customer and so on, and then at the end of 2 years of the development, I know very well my product and the context. There's the internal level, sorry, you cannot reduce the internal level of complexity. You cannot. It's the internal level of complexity. I don't want to... who read the book, The Mythical Month? Okay. Sorry, but there's no silver bullet. That book was written in the 80s, but There's no silver bullet. You cannot reduce internal complexity of software. So, no silver bullet. Technology can be increased, or I hope that at the end will be a very low complexity. You remove all the unnecessary complexity and left only the necessary complexity for your product. And the same for our nomenclature. Okay? I'm talking too much about complexity in not a precise form, so I will introduce the Cynefin framework. Who knows the Cynefin framework? Okay. So it's better that I stop at one moment to explain a little bit the Cynefin framework. Cynefin framework, I will show you the slide later. It's a sense-making framework invented by Professor Snowden, and it's a way to understand and give a name to complex, complicated, obvious, chaotic order and disorder as terminology, to give an exact meaning. I don't care if it is this meaning is absolutely exact, but it's the meaning I use to work, so it's exact for me. Let's divide this area in two parts, and the two parts are ordered and unordered. The ordered part is where cause and effects are connected. With the cause, I have only one effect. Okay? On the other part, causes are not so related to effect. The same cause can give multiple effects. Okay? Example for cause and effects. I enter my car, I turn the key, and the engine starts. Okay? Example of cause not related to effect. I teach to a children to ride a bicycle. The same word with two different children. One got it immediately and started to ride the bicycle, the other no. Because it's not mechanic. There's not a direct relation between cause and effects. I have to use different words with different children. Normally, mechanics correlation between cause and effects are very simple to spot. The other part is the complex part, where there's a relation between cause and effects, but it's not so immediate. It can be multiple, okay? So, for a single set of cause, I can have a lot of different effects. Okay? There's a difference. I call this complex. And this complicated. Okay? If cause and effects are very clear, very easy to spot, I call obvious. Okay? So, I wrap it up. In the Cynefin framework, I have 4 quadrants. In this, on the right side, you have the order part. Okay? Let's start from the order part, in which the cause and effects are clearly very simple related. I call this obvious. If I told you, please copy this file on this sticky, okay? Copy this 3 file on the sticky. It's a clear command. There's no need to other talk. There's a command. The command is copy. Take the 3 file and put on the sticky. No, it's very simple. So you sense, you look at the problem, you understand the problem, so categorize the problem, and you resolve the problem. Easy. Please open the window. There's no problem. Open the window. It's clear. Okay? Second is complicated. There's always cause-effect relation, but you need analysis to understand the relation. And you need specialized people to understand and build it. So you sense, you look at the problem, you analyze the problem, and find the right solution. You can make a plan and resolve the problem. This is complicated. So you look at the problem, say, okay, I understand the problem, I have the skill to resolve the problem, and I can solve the problem. And this is complicated. Okay. This is the case of build an engine, write a program. Computer programs are all complicated. If you can write a test, it's complicated. Because you analyze, look at the data, and say, okay, now I can write a test that describes the result I expect. When you're testing, you are complicated. And then there's the complex. In complex, with the same data, I can have multiple results. I cannot write an exact test for that. I can write a negative test. With this data, you don't have to do that. But I cannot foresee an exact result. It's like to say, okay, if I put my name on Google, this is the exact sequence of answer. It's impossible. Okay? Because Google is not complicated. Google is complex. Because give different results with the same set of data. Okay? And the results are related to the data, but it's not directly testable. It's not so easy to test a complex system. Okay? The last one is the place where, in complex system, you can analyze a complex system, but you don't have a right result. You can have multiple results. And you are not sure that you have analyzed all the possible effects. This is the problem. You don't know if there's 100 possible effects or 1,000 possible effects. You don't know. So you can say, okay, this is a correct effect. This is a correct effect. This is a correct effect. You cannot write 1,000 tests. Okay? You can say this is a negative effect, so it does not work. But you are not sure that works in any case. It's like biology. You are not sure how people react. Okay? Think about a farmer. It's 30 years that you have the same field with the same grape, but you don't know exactly the day of harvesting 1 year before. It's 30 years that you make the same job, and you cannot predict the same effect of 30 years ago. Yes, because it's biological. I cannot predict the exact day to harvest to make a good wine. I have to probe, so make an hypothesis, go to the field, look at the grape and say, sense, yes, everything is okay, now is the time, respond. It's different the approach. You can make all the maths you want, but you have to go to to the field to see if the grapes are ready for harvest. Okay, math is not very useful in this case. So probe means make an hypothesis, sense, execute, and look at the result. Analyze the result, not the data. The result of your work, and then respond. If the result is good, continue. If the result is bad, feedback. Change your path. Okay? Experimental way, scientific method. Theory complex. And then there's chaotic. You don't want to go there. Here there's no relation between cause and effects. Only event. The server is stopped. Why? I don't know. What do you do? Act immediately. Try to turn it off and on. Make a voodoo dance, everything, but put it online now. Okay? This is chaotic. The real emergence. When I go to the company and say, oh, we work eternally in emergency. Okay. Are this house burning? No. Okay. Lower level of emergency. Do you understand what's happened? Oh, yes. Oh, yes means that you are not in a chaotic situation. If you have any idea, you are in a complex problem. In chaotic situation is go, 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 run, out, out, out. Someone makes something. Someone makes something. Okay? You act, and then you look at what you've done. Okay? There's no, you don't have to stop to think. Okay, so, where are our products? Normally our products start from complex. Normally. We don't know exactly what you need to build. So we start from complex. And then we want to go in complicated. Why we want to go to complicated? For one simple reason. 90% of our cost is here. Maintenance. The biggest part of the cost is maintenance. It's not developing the problem. It's to give assistance to the customer, bug fixing, change request, something like that. The very beginning of our development is not so expensive as the final part. It's the longest part. Maintenance. I have to change some part. There's a modification to do. There's bug fixing. Blah 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 blah. So I want to reduce the complexity as soon as possible and come here, because here I have the test, and the test reduce the cost of the software. So I want to reduce my complexity as soon as possible. Okay, this is not real, you know. This is not real. It is unlikely that we finish our product. Normally, we are stuck in a loop like this. We try to finish our product, and our customers say, oh, there's a modification here. There's a new iPhone to build, or there's a new functionality to build. A little change. Transport everything on Android, please. Okay. And something like that. Okay. So you return back to the complex, and we are constantly looping between complicated and complex, and we want to stay on the complicated side as soon as possible. We want to return to have test. Okay. This is a service. This is the 90% of our work, to deal with the customer and say, okay, you need this part different. Okay, I can do it as soon as possible. Okay, I never saw a project finished like I give you the version 3.5 and the customer say, oh, it's finished, thank you, it's wonderful, and I will never touch this software anymore. Yeah. Yeah, was a beautiful word, but it's not existing. Okay, so back to the problem. This is the majority of the cost I have here. I have a little problem for you. Scrum works in this area. I'm sorry for you, but Scrum works well in this area. Why Scrum works well in this area? For two reasons, sorry. Scrum is not so good if you know nothing about your domain. You have to build a backlog. And I don't know how many times you have problem in building backlogs, but it's not so easy building backlogs when you know very few about your domain. And building backlogs is the first part. Extreme programming is more on the complex side, but not too much on the complex side. We can deal in this area where complex and complicated is quite near, but in the deep complex part, deep complex, where deep complexity means that you don't know what you need to know. So it's quite difficult to build a backlog, a proper backlog in this case. It's quite difficult. We can do it, but it's quite difficult. Don't work by the book. Let me say, don't work by the book. Agile can work in both areas, but Scrum as framework has some problem because it's based on planning. Okay? And this is the main problem. Scrum is based on planning. So, here, I cut here. Okay, I consider Scrum working in the obvious domain as dysfunctional. Obvious domain, you can use Taylorism, like project management, okay? You can predict the future in the obvious domain. You don't need Scrum. Don't use it. Obvious, I don't know if your customer pay you to make obvious software. I don't think so. Obvious means something that is so clear that you can predict the future. So you can plan, make a Gantt chart, and the Gantt chart have less than 5% of error on a year. I don't know. I never saw something similar. Okay. So obvious means that you can predict the future. I use planning estimation error as is not an indicator, as a gut feeling in which part of this diagram I think that is more likely that I did. If I have a planning estimation error below 10%, it cannot be so complex. Really, it cannot be so complex because I am predicting the future. So if I can have an estimate of user story below 20%, I'm quite predicting the future. So I'm probably in the complicated area or near the complicated area. I'm predicting the future. I can write a test and execute it with success. Okay? We use user story here. Okay. So, when you have an acceptance criteria, you define an exact solution for the user story. For definition, you link cause and effect, so you are in the complicated area. If you have problem to define an acceptance criteria, because you need a lot of acceptance criteria, maybe it's time to think to reduce that user story. Cutting the user story, extract the complicated part, left the complex part, reduce the complex part. TDD is perfect to slice complex part and transport in the complicated area. Is our work. TDD works well in this area. Slice the complex part and transporting complicated through testing. Works great. But if you are too much out, if your error in writing user story is 100%, you have the double of error. You think that it will take 1 month, it will take 3 months. It has no sense to plan in this area. Okay? Scrum does not work very well in this area. Your error is too high. You have to change your way of working. If you continue to use Scrum, it's like a lemmings to drawing down. You continue and you make big error, big error, big error. No, change your way of working. My suggestion is try to estimate and plan. But if your error is too high, change your way of working. In obvious, you have good estimation, below 5% of error. You are predicting the future. Okay, you are in the obvious zone. Great. You can use whatever, the way of working, you can use what you want. No problem. Complicated, you have estimation with error. Warning. The error has to reduce. More you produce, more your estimation has to be accurate. Complex, high error on estimation. Here you have high error, too high. Don't plan, please. Chaotic, estimation has no sense. If you think that estimation has no sense, you are in chaotic. If you cannot, if there's no sense to estimate, maybe you are in the chaotic zone, not in the complex. Okay? Let's return to Scrum. How we can deal with that? My suggestion is to run fail to safe experiment. Okay? It's like a spike for who use XP, extreme programming. When you have a complex part inside a big complicated part, you use spikes. So you isolate the part you don't know and run a spike. A spike is like a user story, just require knowledge, because you need to understand what's going on in that area. If the majority of your project you don't know, a way to try to deal with this complexity is to run fail to safe experiments. How they work? They work in this way. Run multiple experiments, try different paths or strategies. You define a target and run multiple experiments for the same target. Okay? The target has to be measured in working software. We are talking about Agile. So the only measure is working software. You run an experiment that produces working software, and you run on the same part two different experiments with two different parts to produce the same working software. It never happens. You produce two different versions, and you learn a lot from that. Okay? Use a small team, not big team, not Scrum team. 4 people, 5 people maximum. Okay? Define action and this coherence. You need a target. So, I wanted to understand how works this, geolocalization of satellite images. Okay. I have to define the action I want to perform, and why is coherence to have a coherence to my project. Define an overtime, not a time box, an overtime, just a watchdog. After 2 months, stop it. Too much time, stop it. This is a failure. Okay? You need an overtime for failure. Define leading and lagging indicator. You have to declare the ball in the hole. Okay? So you say, I want to run this experiment. I expect this leading indicator. So leading is an indicator that look at the future, and lagging indicator. So lagging indicator is an indicator that told you if you're right or wrong. Let me say. Your estimation in a user story is a leading indicator. You are trying to predict in the future. When you finish your user story, at the review meeting, you look at the user story, you understand the user story, the error of your estimation is the lagging indicator, and it is exact. It's a data. It's data. One is an idea, the other is a data. Because A lagging indicator is in the past, so it's exact. Leading is in the future, so it's not exact. But you need both, okay? Define expected success condition. Okay, if this happens, is a clear success. If people run, you need to define a clear success. Define some clear failure condition. And define the middle, that is the normal, as normally the experiment ends. There's a clear success, there's a clear failure, and there's all the middle, all the gray zone. You are in the complex domain. You cannot predict the future. You cannot, okay? In this case, define action in case of failure and in case of success. Define everything before start the experiment, not during the experiment, okay? This is important. And then run the experiment. When you have all this, you need the review meeting. You know the review meeting? The review meeting is a technical meeting in which you analyze the result. You here are moving the complexity. You are cutting a very big slice of complexity and try to make an experiment and produce some result that you can analyze in the complicated zone. Okay, so use the review meeting to analyze the result and to keep the lesson. You need to learn to exit from the complex zone. The target is to exit from the complex zone. So, here, run fail to safe experiment. How you change your way of working? You can use a Scrum. I suggest extreme programming in running a safe to fail experiment. Because teams are small, you don't need to plan. You don't need to plan too much. You need to have a good review meeting, very good review meeting. You need to analyze the results. Okay. Who runs Scrum here? Who runs Scrum? Okay. Okay, so the final part of my talk is how to adapt Scrum for this different zone. I don't want to talk about Office. I don't want to talk about chaotic, because in chaotic there's only one rule: exit. Run out of there. Make everything, but you have to return to the complex zone. There's no free lunch. You can go from chaotic to obvious. You can go from obvious to chaotic, but not vice versa. It's one-way route. How we go from obvious to chaotic? Just an idea. A shell script in a server ran for a lot of time, but the file was not on the same server anymore, was on the cloud, and the file was written by programs that think to write on a local file, and this program was written by a web server, and there was a JavaScript that now automatically writes this program, and we lost all the database of customers. So, was a simple file, was an obvious file, was stay here, it worked for 20 years, wonderful, really obvious. And then one day, we have no more the DB of our customer. And you are in chaotic zone, you don't know why. Okay? It's possible to go from obvious to chaotic. But to resolve the problem, you have to say, okay, I know nothing. I have to start to make an experiment. Why it's happened, and so on. It's not so easy to come back home. Okay? Okay, so Scrum, I'm sorry, I don't have the time. I'm quite over time, so I don't have the time to explain how Scrum works. Sorry for that. for people that know Scrum, I strongly recommend you can make everything you want. I saw dysfunctional Scrum with the PO out of the team that decide everything, the Scrum Master acting as team leader and so on. But please, if you want to change your way of working, never reduce the time for retrospective. Retrospective is the key ceremony if you want to change your way of working. To change your way of working, all the strategic decisions are taken in the retrospective. All the tactical decisions are taken in the daily Scrum. So, the strategy to change your way of working, you will decide in the retrospective, where you see all the data and say, okay, we are in trouble, we are not so good in planning, we have to change, try this, and you change your way of working. Never underestimate the value of a retrospective. In daily Scrum, you take your daily decision, you have the tactical decision. I don't want to talk about these two because it's too important to change the timing of this ceremony. Retrospective each weeks or 2 weeks, Scrum, daily Scrum daily. Review meeting. Review meeting is absolutely necessary in complex zone. Review meeting is the key ceremony if you want to run out of the complex zone. Is the ceremony in which you acquire technical knowledge. If you talk with your customer looking at the product during the review meeting. So you reduce the cultural problem, you reduce the unknown problem, and you reduce the technical problem here. The technical complexity, sorry, here. Okay, review meeting. Planning meeting is very useful in the complicated zone. It's quite not so useful in the complex zone, so reduce it. Backlog refinement, if you don't know, if you cannot build a backlog, backlog refinement is not so useful. Think about to reduce it or to increase it in the moment in which planning meetings start to work. Okay? So, my suggestion is, if you cannot plan, don't continue to plan and have a big error. Try to stop planning, try an experiment, acquire knowledge, and come back in a zone where you can plan. Increase the time for review meeting and decrease the time for planning and refinement, please. As soon as you can plan, immediately increase this time. This is time, okay? It's just an idea how you can change your way of working to adapt to your product. If you are not able to plan seriously, if your error is over 100%, you need knowledge, you need something to change this situation. So try to run some fail-to-safe experiment and return in a zone in which you can plan. If you plan, if you are here, if you are an error below 10%, please stop to waste time looking at your product. You are predicting the future. You own your product. So reduce time for review meeting and to refinement. You don't need to estimate in that. Really, you stop to estimate. If your estimation is below 10%, stop to estimate. Start working. Okay? You don't need to estimate too much here. Oh, sorry. Too much. Okay, you don't need to estimate here. Okay? You need only here to estimate. Reduce the time for estimation. Here you are predicting the future. That's not so. You need just to put to create the backlog, the sprint backlog, and run to work. Okay, so this is the last, and I finished. change your way of working continuously through the retrospective because your product changed. The need of your customer change. If you're using Scrum and think that Scrum works for every part of your project, I think that you are optimistic, at least. Okay? So Scrum is just a way of working that you have to modify for your need. Follow your need. Find your own indicator. I show you one way, one indicator. Find your own indicator. Finished. Questions? Some questions? Was too theoretical, okay. Domande? No, una domanda.
Yeah. So, the main issue here is that we know the situation, we define our level of complexity, that's where we are, and choose our framework wisely.
Yeah, I don't know if you can define your position on Cynefin framework. What I want to say to you is that if you have a problem in your way of working, if your planning are not so good, maybe there's some hidden complexity in your product. Maybe there's some part that you need to change your way of working. So it's not you that are not able to make prediction. Maybe it's your product that is impossible to predict because it's complex. So you can waste a lot of time trying to predict the future of a complex system. You are wasting your time and your team time. So don't waste that time. Try to run a safe-to-fail experiment. Put some indicator, and if you're right, that experiment will succeed. So you don't waste time trying to predict the future of something that is unpredictable, because it's complex. So try, during the retrospective, try to analyze what you are doing, and say, oh, maybe it's not my fault. Maybe there's another reason for that. Normally, we try to keep our... Is that the response to the answer? Answer to the question, sorry.